when you're doing different, say, a mega-analysis combining public data in your study or several public data sets, how do you harmonize those genotype calls both within the same array type or crossing across different arrays? And there's where we want to use the imputation capability to combine studies. So in order to be able to combine studies, however, you want to minimize as much as possible the batch effects. So BEAGLECALL, as opposed to BEAGLE, so there's two things. BEAGLECALL is a way to use haplotype phase information to do a better job at calling. And BEAGLE is the actual haplotype phasing. It turns out BEAGLECALL actually is a pre-processing step to BEAGLE, and it runs together. So what BEAGLECALL is all about is dealing with the problem of clusters are not clearly separable. And I'll show some pictures of that. And it turns out you can use neighboring SNPs that are correlated or in high LD to improve genotype accuracy. Think of it as taking advantage of parallel reliability. So if I have a SNP here for 1,000 patients and this next SNP beside it, this SNP may be noisy, and even the one next to it, the 5 SNPs around it, may be fairly noisy, but maybe their call rate's 90%. Well, if you take 90%, 90%, 90%, 90%, and there's a high correlation because you can infer the haplotype, you can get up to 99% or better accuracy through that parallel reliability of many 90% confidences. And so here's the paper from Brian Browning in the American Journal of Human Genetics. And he shows this nice example where the Chiamo method, which was the method the Wellcome Trust developed actually specifically for that large 14,000 sample study. And here's a particular SNP where they've got the A allele, and in this case it was a G allele. And you have these 3 clusters, the homozygous GG, the homozygous AA, and the heterozygous. And there's all this ambiguity between. Now, what BEAGLECALL can do is actually deal with the case when the clusters are so overlapped that it's actually disentangling overlapping clusters. Now, people look at this plot and they say, well, how could you say that those blue ones are really GGs and that is AG? Well, remember, it's not just looking at one SNP, it's looking at neighboring SNPs as well. And they were able to verify using HapMap calls that had been typed across multiple arrays and had very high confidence that even though it didn't perform well for, say, this array, it performed well for some other array, and they were able to confirm very high accuracy with their calls. So when they look at the discordance rate of BEAGLE in the solid line as opposed to Chiamo or birdseed, they had very low discordance rate, let's see, this axis is the uncalled genotype percentage. So you can sort of accept lower or higher thresholds of certainty, and so if you allow very low percentage of uncalled genotypes, you'll have more errors. But even in the worst case, they were at better than 5% discordance rate when they essentially called everything. Or if there's certain less confident calls, if they allowed a 1% missing rate, then their discordance was also somewhere around 1%, whereas they were up here at closer to 5% when they allowed 1% missing for Chiamo, and for birdseed it was more like 10% discordant if they allowed only 1% missing. So, and similarly, you can use this method on Luminas genotypes. And so when, remember Rudy showed you the export, you could export the A and B allele intensities, in which case you actually want to export the normalized A and B intensities, and you can do a better job at Illumina than calling their genotypes. Now, it turns out that BEAGLE needs some initial calls. So you have to use some other method, whether it's birdseed or if you're using AFI, or use Luminas initial calls as a starting point, as well as the intensities. So it takes as the input genotype calls called with some other method, plus the intensities for the A and B allele. Now, to show you, this is a study we were involved in. We took one of our collaborators was using the gain bipolar study. So we used C-realm, which publications have shown that C-realm had better performance than birdseed and other methods. And yet, when you look at the association tests, there's a lot of spurious associations. Again, they ran their cases and controls in separate batches, and the problems with the is that the calls were correlated, errors in calls and so forth, miscalls were associated with batch. When we use BEAGLECALL, it essentially removed these spurious associations. Now, BEAGLECALL does do some filtering of SNPs in that if there's big departures from Hardy-Weinberg or very low call rates after there are multiple phases of calling and imputation. So, but this is apples to apples in that we use the exact same set of SNPs that were called in BEAGLECALL as C-realm, and we still had a lot of spurious calls with C-realm. So we actually were able to do a mega-analysis using the Wellcome Trust bipolar plus the gain bipolar, and we did not have any spurious associations when we imputed it up to 6.0. So the Wellcome Trust was 500K, and the gain study was AFI 6.0. We imputed them together up to the 6.0, and we didn't have any spurious associations.
I have a question. You said that you filtered out the SNPs that have spurious associations. So how did you determine that this association is spurious based on what?
Well, there's no signal, so.
Okay, right at the beginning,
right.
So you determine that.
And in fact, you know, the other studies people have done on bipolar for this, they came up empty, just nominally significant findings. So these here, in a sense of, if we say 5 times 10 to the minus 8 is genome-wide significant, clearly there's lots that are above that 5 times 10 to the minus 8 with C-realm, and there was none above 5 times 10 to the minus 8 after BEAGLECALL. So in a sense, there's no signal, so there's no spurious associations. The original study didn't, you know, after they looked at cluster plots for all of these, they would have dropped them.
Is it based on the visualization graphical methodology, or it's based on the test, how you filtered out this spurious?
So the filtering that does occur in BEAGLECALL doesn't look at the phenotype. It just does a if Hardy-Weinberg p-value is less than 10 to the minus 6, it discards it. And if the call rate was below 97%, that's the default. Okay, so we could have made it more lax, and maybe there would have been some more spurious. We have seen some spurious associations for BEAGLECALL in other studies, but largely it's the lowest we've seen in any methodology. It's not perfect, but it's much better than we've seen with any other calling method. Is that what you're?
Probably I will ask you later, okay. Because I was using the R software, the packaging that come with R. I just wanted to compare what is specific about the BEAGLE which R does not have. But I may ask this question.
Is there a R package that encapsulates BEAGLE?
Not BEAGLE, but they
C-realm maybe?
Genetics, also
genetics impute.
You're thinking about impute. So remember, this is not actually doing imputation at this point. This is just, it does phasing and so forth.
Genotype. Genotype. I use Genotype.
G-E-N-A-B-L-E?
G-E-N-A-B-L-E.
ABLE, A-B-L-E? Yeah, I haven't used it, so I'm sorry I'm not
It was
familiar.
initially designed for genome-wide association analysis using family designs, but
Yes.
with parametric modeling, so as a counterpart to that.
Now BEAGLE can, you can give it pedigree information, it can do an even better job because then it can use the, look for the Mendelian problems and so forth. Well, I'll go on and we'll talk some more if you still have questions. So here's the QQ plot for the C-realm on the bipolar study from GAIN. You see all the inflation of type 1 error, whereas here it is with BEAGLECALL is very close to hitting expected values. Now we've been able to use BEAGLECALL on some very low quality samples. This was C-realm, we had real problems with this data. The average call rate was somewhere between 85 and 90% per sample. Birdseed did better, but a call rate is not synonymous with accuracy. So often, you can call 100%, but be 50% wrong. It doesn't mean anything. But the BEAGLECALL's call rate was extremely high, as well as it was confident. The missing rate was better than 97% for everything that it called. So nice thing about BEAGLE is their confidences that they report are very, very close with the actual error rate.